everyone, and welcome to the last part of this end-to-end data engineering project where we are web scraping the flights from the Ryanair website and store the data into the MySQL database. In this video, we are going to extract the data from the database and calculate the flight's weighted degree centrality. Later on, we're going to visualize it with matplotlib library. So in order to understand what is weighted degree centrality, let's first talk about degree centrality itself. Imagine you're looking at how many friends a person has on a social network. This is the degree centrality. It's just the number of connections. If you consider that some friendships might be stronger than others, you would weight those connections. So instead of just counting friends, you also consider the strength of each friendship. How is it related to our flight's data? Weighted degree centrality would mean looking not just at the number of flights on each route, but also at the frequency or weight of these flights. A route with many frequent flights would have higher weighted degree centrality than one with only a few flights. Counting the number of flights would be the total number of direct flights connecting to airports. It only considers how many connections there are, regardless of how often they occur. So if an airport, in this case Amsterdam, connects to 3 others with any number of flights, its degree centrality is 3. Frequency or weight considers not just the presence of flights, but also how frequent they are. For example, if airport A has daily flights to airport B, but only weekly flights to airport C, the route to B would have a higher weight than the route to C. Weighted degree centrality will be higher for routes with more frequent flights. So let's get started with the code. I've created a new file called weighted degree centrality, and I indicated the connection parameters to the database. Next, you want to get the flights data from the database. As you already probably know, we need to initialize the cursor in order to get the data from the database. So cursor equals to connection dot cursor. Then we need a variable which will store the query. Our query should be very simple, including only a select statement with 2 columns, origin airport and the destination airport. Next, we want to execute the query. Cursor execute, and here we want to write down the query. Now we need a new variable called flight data, and we want to assign all flights to this variable. We need the method fetch all. After that, we want to close the cursor and return the flight data. Once we have the function that gets the flight data from the database, we need a function to create a weighted graph and calculate weighted degree centrality. So the networkx library from Python will help to do that. So we need a graph, which will be called G, and we need to call the nx diagraph. Now we want to add the edges to the graph with weights based on the number of flights on each route. So here we want to iterate for origin and destination in the flight data. We want to make sure if the graph has edge, origin and destination. If it has the edge, then we want to increase the weight of route that already exists. So we go with G, we say we want the origin, then destination, and the weight. Here we are increasing to 1. In another case, we want to initialize the weight of new route. So we need the G and the method add edge with the origin and destination, and the weight is gonna be 1. Now we want to find the root with the highest weight. So the most popular root equals to max edges. We want to say data equals true. And the key equals to lambda. So the edges, data equals to true, generates a list of edges in the graph, where each edge includes data about the connection. The true parameter tells it to include any additional information stored with each edge, such as the weight. Each item inside is a tuple that contains of origin node, destination node, and data dictionary. This part finds the edge with the highest weight. The max is finding the maximum item in the list, where maximum is determined by the function defined in keys. Now we want to unpack the tuple returned by the max function into 3 variables: the origin, destination, and the data. The data variable includes the weight, and all that we want to assign to the most popular root variable. And now we gonna retrieve the weight of the most popular root from the data dictionary. For this, we want to write the root weight equals to data weight. So, for example, imagine you have a tuple like this. It means that there are 10 flights between airport A and the airport B. And now we want to return the origin, destination, root weight, and the graph. The graph we need for our next function, visualization. If you do not want to visualize the graph, you can skip that in the return statement. So now let's move on to the next function. And here we want to first initialize the layout for visualization and x string layout. Now we want to get the attributes from the graph and the weight. And next we're gonna draw the nodes, nx draw network nodes. For this we need the graph, layout, node size, and the node color. Let's make it sky blue. Next we're gonna draw the edges with thickness based on weight. So the thicker the line is, the more weight it has. Nx draw network edges. And let's take the graph here, the layout, the edge list, which will equal to the weights keys, the width, and here we want to iterate through the weight for weight in weights values. And we also want the edge color. So we will make the edges blue. We also want the arrows equals to true and the arrow style. So now let's draw the labels for nodes. Nx draw network labels. We need the graph, the layout, the font size. Let's make it 10. Font family will be sans serif. And now we need to draw the edge labels. So let's go with nx and the method draw network edge labels. So you want to pass on the graph as usual, the layout, and the edge labels equals to weights, and the font size is gonna be 8. So let's have the title of this visualization. Let's call it flight routes visualization. And then we need to call the method show. All right. Next, we already have the variable that retrieves data from the database. Then we are calculating the most popular route, and we are printing out the most popular route. We'll visualize the routes and we close the connection. If you're using Mac and if you're using Python 13, make sure you start the virtual environment with Python 12. The instructions how to start virtual environment simulating Python 12 you can find in the README file. I've already created the virtual environment with simulation of Python 12, and now I need to activate it. The reason why I'm doing that, because with my current version of Python, it's impossible to run this file. So it's impossible to run the matplotlib library with my current version. So that's why I need to simulate it to use the networkx library and the matplotlib library. So now let's run the script and see the most popular flight in our database. So we have the message here. The most popular route is from Vienna to London Stansted with 10 flights. So let's calculate the flights here. If it's really true, I have it here. And it does have 10 flights from Vienna to London. So let's see the visualization. This is our graph. And as you see, the edges are those small bubbles that also have the name of the airport. And here you have the numbers that indicate the weight of the route. Also, the second indicator how high the weight is the thickness of the line. So if you, as you see, the closer the bubble is and the thicker it is, the higher weight it has. So our statin is here. So thank you for your attention. Please subscribe to my channel for more similar projects. And if you like it, click the thumbs up and follow for more. Thank you.